Hey everybody, and welcome back to the channel. Those of you who saw my 8BitDo retro video know that I issued a bit of a challenge, mostly to myself, but also to others in the community if you guys wanted to join in. It was a little subtle, but I went on eBay and I found a Nintendo Zapper. So you guys know what that means. It is time to tinker. Okay, so I got this Nintendo Zapper on eBay for $5. And it's in the gray colorway, which I feel best complements the keyboard and mouse. The seller also included 2 Nintendo cartridges and asked for a positive review. Well, RL Welder 7, I'll do you one better and give you a shout out to my tens of fans. So let's go ahead and begin the disassembly. The Nintendo Zapper has about 6 Phillips screws and 2 flatheads. 3 in the outer light gray bezel, and then 1 under the bezel and 2 in the handle. And then there's also 2 flathead screws in the barrel. Once you get that part disassembled, the interior housing, there's 2 weights. Then there's the trigger assembly with an Omron switch and a photo sensor that actually senses what's going on the screen. We're going to disconnect the proprietary Nintendo cable here and put that to the side because we won't need it for the next part. Here you can see a little bit close up of the solder job they did between the photo sensor and the Omron switch. We're going to desolder that off screen and clean it up because we're going to use slide connectors instead of doing soldering. And then, like I mentioned, this is the Nintendo cable. We won't need that, so we'll go ahead and put that to the side. Hopefully, we won't need it again. And then from here, you can kind of see the channel where the cable went as well as the weights. We'll try to reuse that channel for our cable that we plan to use. Now that everything's kind of set aside, we can kind of do a little bit of a quick example on how the Zapper actually works. You have the trigger. When you squeeze that, it actually closes the circuit of the normally open circuit on this Omron switch. And that then sends a pulse through the photo sensor, which basically records what's on screen, sort of. So here we're going to do a little bit close-up of the switch. And you can see there's a 3 amp rating. And it's 125 volts DC as well as 250 volts AC. Those are the ratings for the switch that's in the Zapper. You have a normally open pole here as well as your common pole at the bottom. And then a momentary switch on the very top. This is what you press to activate the switch and close the circuit. When we flip it over, you can see there's a little bit of a diagram. We'll do a quick electrical example here. There's actually a normally closed pole on this switch, which has been shaved off, which I would assume is to save space. And that's what I'm marking here in red. So if you find a replica of this switch online, it may actually have 2 poles natively. And right here you can see NC, which stands for normally closed. So if the circuit was always closed, you'd always have a signal going through it. And then when you press it, normally open would open the circuit. And then you have your switch here. So with the circuit being normally open, it's open until you activate the switch and close the loop, basically. So when you activate the switch and close the loop, you go from your common wire through your normally closed and send a pulse back out to the photo sensor. For those of you who miss Duck Hunt, there's actually a couple of apps, one on the Android, and a few on iOS. The problem with this Zapper is that most newer TVs post-process images, which can be difficult for tracking where the objects actually are on the screen. And that's kind of how Duck Hunt and the Nintendo Zapper worked. There was a pause between you squeezing the trigger, which actually tracked a white square. There's a couple of videos on YouTube that explain this a little better. And here are your iOS options. Okay, so now for the reassembly process. I just grabbed a basic 3.5 millimeter to RCA cable. We're going to clip one of the sides. I had the bright idea that more than likely, based on the AB buttons and it being a stereo connection, your left channel was one macro, your right channel was one macro. So what I did was I took one of the channels on the RCA end, cut it, and I'm taking the common wire, basically the shielding wire that's around the signal wire, and that will be my common. And I'm just using these crimp-on slide connectors. That way I can pull this off quickly and swap it back to its original setting, just to avoid the Nintendo lawyers. And then my signal wire is going to go to the normally the normally open wire. And hopefully whenever we squeeze the trigger, we'll get a signal out the red wire and use the shielding wire as our common, which will keep our circuit closed whenever we hold down the trigger. All right, so now that we kind of have everything kind of soft wired, so to speak, before we close it up, I just put 2 screws in it. We're gonna go ahead and test it to make sure it works. So as you recall from the previous video, you have to hit the start button, it starts blinking, and then you hit your macro. So we're gonna do shift, the command key, and Q, which would be to lock the screen. So we're gonna do that, and then we're gonna squeeze the trigger, and we should be good to go. Voila, it works. So now we can button everything else up and get it a little bit more cleaned up and set up. Just again, so you guys know this isn't a fluke. And there's our option to lock the computer. Okay, so now with a little bit of electrical tape, we're gonna get this guy buttoned back up and ready to hook up to the keyboard. Okay, so while we're getting this button back up, the intent is to 3D print a dock for the desk and go with the whole retro arcade vibe. So we're gonna do a couple other things as part of the retro reset for the desk that'll probably come up in a later video. All right, guys, that's gonna do it for this video. If you like seeing stuff like this, make sure you like, subscribe, and hit the bell so you get notifications anytime I post new content. I'll probably be posting the STL files for the holster I made to go on the desk, and more than likely any of the other parts and pieces I use to make this thing. So if you're interested in that, look in the descriptions down below, and I'll see you guys on the next one. Later.